Welcome back. Our next panel deals with a different aspect of climate science, the science underlying our current understanding of climate risks. This panel will be moderated by Maria Zuber, MIT's Vice President for Research. Maria is a member of the National Science Board and is the E.A. Griswold Professor of Geophysics in the Department of Earth, Atmospheric, and Planetary Sciences. Please welcome Vice President Zuber, who will introduce the panel.
Okay, good afternoon. I can't even begin to tell you how thrilled I am that we were able to fill up Kresge this afternoon on this important topic, the first of 6 that we're going to cover over the course of the semester. And let me just say that one of the things that we're trying to accomplish here is to both educate and engage the MIT community. So we're hoping that this is the beginning of everybody coming together and helping us think about basically how we dial it up. So we've started the plan for action for climate change 4 years ago, and we need to take it to the next level. We're not looking to just do part 2, more of the same. We're trying to think hard about how we really ramp it up, and we need lots of ideas and lots of commitment from the folks here, from our alums, from actually everybody in the world that we can engage with. So, so this is the beginning of that conversation. Okay, so we've got another amazing set of experts with us here today, and starting over there on your left. First of all, Jerry Mitrovica, who's Professor of Science at Harvard University. He's a geophysicist and has just been named to the 2019 class of MacArthur Fellows. So congratulations on that, Jerry. Okay, then Sherry Goodman, who's a senior fellow at the Wilson Center. Phil Duffy, who's president and executive director of the Woods Hole Research Center. And John Riley, co-director of the MIT Joint Program on the Science and Policy of Global Change here on campus. So I'm going to begin with a question for Jerry, and I'd like to let's build on some of the foundation that Susan Solomon laid for us in her excellent keynote address earlier. Let's talk about future sea level rise and sea level changes, and let's talk about how that happens. And sea level is, since I'm a gravity person here, sea level is a geopotential surface. So why isn't sea level going to rise the same all over the Earth? And so why in the future might the sea level rise that's experienced be different in Boston than, say, Melbourne? And so if you could maybe educate us a little bit on this topic.
Yeah, sure. So I usually start by saying I'm a Canadian. I don't know why I start by saying that, but I'm going to quote a politician who when I was a student, was important here, Tip O'Neill, who said that all politics is local, and all sea level is local as well. There's no getting around that. But let's step back just a second and ask ourselves why the risk of sea level change is important to talk to in an event like this, and why that risk varies from place to place. Now, if I was in my sea level graduate class at Harvard, I'd be talking about things like coastal erosion, I'd be talking about degradation of wetlands, barrier islands, etc. But I don't want to do that here today because those are general sort of textbook ideas that you've probably heard about, right? And when I talk, all of us here don't worry as much about global mean sea level rise. Well, you should worry about global mean sea level rise, but the more important thing for most of us is what sea level is going to do in our backyard. So it's important to start with examples that are local, because it sort of hits home harder, I think, than a textbook discussion does. Right? So if you live in Miami, for example, you're going to be worried about the fact that land and houses are becoming more expensive as you move to higher elevation. And so what is that doing, right? Gentrification of sea level change, they call it, right? That means the wealthy who are living near the shoreline in general are starting to move up to higher ground, and they're displacing people, long-term residents, lower income residents. That's what you're seeing every day. If you live in Hull, Massachusetts, you worry about sunny day flooding. That's probably a term most of you haven't heard about, because all you hear about in the media is flooding at storms. But flooding is happening at high tide all along the US East Coast, and it's happening at higher and higher rates. I had a colleague tell me last night when I was thinking about my remarks that it turns out, and I haven't verified this, that in Hull, Massachusetts, you can predict when those sunny day floods are going to happen, and so school buses know to take different routes on those days. That's something that hits you quite hard, right? Those sorts of issues are everywhere in sea level research, right? They're these everyday issues that don't really get the attention that perhaps they should. But now let me sort of start to answer Maria's question. Right? So we're in an unfortunate situation on the coast of the United States. Right? There is a contribution to sea level rise along this coast that has nothing to do with our damage to the environment, and it's the Ice Age. Right? So 20,000 years ago to 5,000 years ago, there were large ice sheets that covered all of Canada, my country, and a good part of the northeastern United States. And when they were there, they caused the crust to depress. And outside of them, so along both the east and west coast of the US, they produced land moving upwards, these so-called peripheral bulges. And so as those ice sheets melted, the land beneath those ice sheets popped up. That has a name, it's called post-glacial rebound, and those bulges began to subside. So if you live on the East Coast, even if you lived there in the year 1800, you would have experienced sea level rise of maybe 2 to 3 millimeters per year from this natural effect. So this adds another factor to what we're now doing to our climate. Because it's inescapable, there's nothing we can do about it. It's an inexorable sea level rise on both those coasts. Right? So we get a double whammy here. But now let's talk about how sea level will change if an ice sheet melts. This is where I'm going to really challenge your intuition, right? Because the bathtub idea of sea level change is incorrect. The idea that it will go up evenly, as Maria just implied, is completely wrong, and it's wrong in a dramatic sense. If you melt an ice sheet or a glacier, you do three things. You put water into the ocean, so you increase the mass of the ocean. That's number one. The second thing you do is you cause this pop-up of land, right? The third thing is very counterintuitive, but it's really just Newton's law, and that is that an ice sheet exerts a gravitational pull on the ocean. So when an ice sheet melts, water is gravitationally attracted with less force towards that ice sheet, and it moves away. So local to an ice sheet, the land coming up and this gravitational effect of water moving away means that close to a melting ice sheet, sea level will actually fall. And it's a dramatic effect. It isn't a small effect. If you believe the bathtub scenario and the Greenland ice sheet melted away entirely, then sea level would rise 7 meters everywhere. But in fact, if Greenland ice sheet were to melt tomorrow, sea level would drop about 50 meters at the shore of Greenland. It would drop in Iceland, it would drop in Ireland, it would drop in Scotland, Newfoundland, etc. So if you had a friend who happened to live, let's say, in the Netherlands, and you knew that Greenland was about to collapse, you might call them, but your concern would be misplaced, although you should have a humanitarian concern that you know that the Greenland ice sheet is about to pop off, right? Because sea level would stay relatively stable there. But you pay the price further away from that ice sheet. Sea level will rise at progressively higher amounts, so the southern hemisphere will be hit hardest if the Greenland ice sheet melts. The opposite is true if the Antarctic melts. If the Antarctic ice sheet were to melt, sea level close to the Antarctic would fall, and it would rise at progressively higher distance. It would rise significantly higher, 30, 40, 50% higher than if you believe the bathtub model of sea level change in the northern hemisphere. We received an incredible amount of pushback and angry emails when we published a paper 10 years ago that showed if the West Antarctic ice sheet melts, the highest sea level rise that is going to be observed in North America will happen just off the coast of Washington, D.C. Right? So that's an inconvenient truth if I've ever heard one. Right? So in addition to that effect, you have fingerprints, and one of our speakers talked about it, of thermal expansion, that as you warm climate, oceans are going to expand. You will have sea level changes there, and we need to know the fingerprint of that. And we have ocean dynamic fingerprints. If you're changing climate, you're changing atmospheric winds, you're changing ocean circulation, there'll be a dynamic effect. Right? So we understand, in the last 10 years, there's been a revolution in our understanding of each of these individual agreements. But if you move forward, and Maria asked me to project, uncertainties become larger. But uncertainty is not the same as risk. Because whatever happens, however we combine these ingredients, the ones I've talked to, it's not going to be pretty, right? And the question is, which areas are going to be hurt the most? Which will sort of escape the worst part of that? And without exception, when I talk to friends who study the impacts of climate change, the fact is that lower income people, indigenous communities, are the ones that are going to face the largest impact, no matter what this recipe that combines our ingredients will be. The biggest risk is to them. And sometimes I think that this hesitation to deal with climate change comes from the fact that those people aren't as politically active or have the political power than wealthy people in Miami who are allowed to move up to higher elevation are.
Great. Thank you, Jerry. Okay, so we're going to move on to ask Sherry the next question. And getting a little bit more pragmatic into maybe the socio-political area of risk. You were the first to describe climate change as a force multiplier.
Threat multiplier.
So what does that mean, and why is it important in this context?
Okay. Good afternoon. It's a pleasure to be here with all of you. And from a national security perspective, which we should all as global citizens have, we described about 12 years ago, coined the phrase threat multiplier to describe the impacts of climate change on our national security. Because the elements of climate change, sea level rise and heat, drought, extreme weather events, deforestation, changing ocean circulation patterns, and ocean acidification all amplify and aggravate in different ways our national security challenges. I have worked for decades now with our military leaders. I served in the Department of Defense and on the Senate Armed Services Committee, and with about a dozen years ago, with about a dozen senior retired generals and admirals, we started this work on national security and the threat of climate change, and now have been joined by scores of other military leaders, both active and retired, both American and international. We now have an international military council on climate and security with over 24 countries represented. So let's just unpack that a little bit. I'll just give you a couple of examples of how climate change both emboldens our adversaries and degrades military readiness. So in the category of emboldening our adversaries, the Arctic is really the best place to see that change. We have a whole new ocean that has opened up in our lifetime, and an area that is now increasingly navigable for more than a few weeks of the year, with Russia having looking to monetize the northern sea route, its Arctic coastline. It has the largest Arctic coastline, and to extract both oil and gas and other minerals and energy resources, and at the same time to make it almost a toll road for Arctic transit. And you have China now declaring itself a near Arctic stakeholder in its first Arctic policy issued last year, constructing the Polar Silk Road as an adjunct to its larger Belt and Road Initiative, which will connect by road, rail, and sea lines of communication, most of which today in Asia and South Asia and the Pacific are controlled by the US, but in the future across the polar Silk Road, either through the Northern Sea Route or eventually through the Central Arctic, will not be controlled solely by US forces. So you now have competition for resources, economic competition, you have Russia militarizing its portion of the Arctic and increasing tension in that region. Simply because the ice has retreated, the permafrost is collapsing, and the oceans and the temperature are warming. It was up to 90 degrees in parts of Alaska last summer historically. In the Pacific, you have a whole set of different circumstances. In the South, you have many small island nations that even within our lifetimes could become uninhabitable communities. Kiribati, Vanuatu making plans already to move their populations to higher ground. China seeing the opportunity to increase its humanitarian assistance and natural disaster relief across a region that is experiencing even more extreme storm events and disaster conditions than it is historically accustomed to. And then if you look across the Middle East and Africa, a region that historically was already water stressed, but becoming even more so with climate change, you have periods of prolonged drought that preceded the Syrian conflict, the most deadly of the current era. And it was that drought that drove farmers and herders to urban areas, combined with political instability and oppression, led to the deadliest conflict of our current era. And you have now extremist groups across that region in northern Africa weaponizing water in various ways to hold vulnerable populations hostage. And just lastly, I'll say on the degrading military readiness, how climate change affects our military readiness today. You talked about sunny day flooding. That happens not only in Hull, but it happens in Norfolk, Virginia, which is home of the largest constellation of military bases, military infrastructure in the United States, probably in the world. All services, Navy, Air Force, Army, Marines, and a NATO command post. And the seas are rising there, sunny day flooding, so that people can sometimes not get to work on the base because they can't get from home to the base. Piers are being raised and reinforced. And we have major military bases in Florida and North Carolina just last year took major damage from hurricanes Michael and Florence. And also, finally, we train like we fight. So as temperatures increase on a regular basis, we experience more black flag days, so our troops can't be out in the hotter heat stress that they experience. And that's not true not only at training ranges in the United States, but increasingly in places across the Middle East and North Africa where our troops deploy.
Great. Thank you, Sherry. Okay, Phil, let's move on to you now. Can you comment on what seems to be a growing interest in physical climate risk on the part of the businesses and financial communities?
Sure, thank you. Thanks for the question, and thank you all for being here today. I'll answer that question by putting it in the context of the work that we do at Woods Hole Research Center. Some of you may know us. We are, to some extent, a scientific research organization, but to some extent also a bridging organization, by which I mean a big part of our mission is to bring scientific understanding into real-world policy processes and real-world decision-making processes. And lately, I and others at Woods Hole Research Center have been working with folks in the world of business and finance about physical climate risk, by which I mean risks from things like extreme weather. And I'm contrasting this to what's sometimes called transition risk or policy risk, which is more like, what do we do if there's a carbon tax, okay? This is, how likely are we to get clobbered by some extreme weather event? And I guess I'll start by asking the question, why are we doing that? Our mission, again, at Woods Hole Research Center is to bring science into decision-making processes, but what we want to see from that is progress in controlling climate change. Our mission, frankly, is not to help businesses make more money. If that's an incidental consequence of our work, that's great, but what we're really looking for in everything we do is broader societal benefit. And in terms of working with folks in business and finance, I do see real potential for very significant and powerful societal benefit. One thing in particular being that, well, the private sector can influence things in a lot of ways. One thing is they have the power to allocate capital. And right now, I still see a lot of capital being misspent. For example, investments in real estate in regions that are very, very flood prone. And the less of that happens and the more that we can prevent that from happening, that produces societal benefit. Perhaps more importantly, I think when corporations see the proximity of physical climate risk and the scale of physical climate risk, I think, and I'm starting to see this, that they will be moved to take action to reduce their own contributions to climate change, to reduce their own greenhouse gas emissions. And finally, I believe and I hope, that, again, that when corporations and businesses see the scale and the scope of physical climate risk, that they will be moved to engage politically on this subject. And as we all know, they do have a powerful political voice. I'll say just another comment about how we're approaching this work. You may have noticed, if you look closely, that there is, I think, a growing cottage industry of for-profit providers of climate risk information, specifically targeting the financial community. And I frankly have, well, I have some misgivings about that approach, and it's largely based on the paradigm of, well, selling information tends to produce secrecy. The scientific methods that are used to calculate risk tend to be secret. The data themselves tend to be secret, and this limits the broader societal benefit. The way we're approaching the work is in a much more open and transparent manner. We publish all our methods in the peer-reviewed literature. This ensures some level of quality, scientific quality, and what we're doing, and it also allows other people to take what we do and build upon it. And so our approach is to do the best possible work to give away the results at essentially no cost. And we also try to work with partners who can provide critical translation services. Because giving a decision maker a data set is one thing, but showing them how to interpret it and how to use it and really make decisions with it is much more important. And so, for example, we've been working recently with McKinsey & Company, a big global consulting firm, to help them understand physical climate risk so they can work more effectively with their own clients. So I'll just close with a couple of reactions from my own personal experience and having engaged in this work. And one thing that's been surprising to me is how useful to real-world decision makers is information that to us as scientists is very, very rudimentary. And if you were here for the last panel, I think you heard the word uncertainty probably a couple hundred times. And certainly there's a lot that's uncertain about climate science, but it's also true that we know a lot. And if you've never considered climate science before, if you've never looked at investments, for example, through the lens of physical climate risk, then even information that's, to us, again, very, very rudimentary, it's going to get warmer. There's going to be more extreme heat. The Mediterranean is going to be subject to very, very frequent droughts. These fundamental results that are pretty robust, and they're especially robust if you look on relatively near-term time horizons, which is the time horizons these folks are interested in. That information has a hell of a lot of value to those people. The second thing I'll say that's been very surprising to me is the extent to which the folks that we've worked with have resonated to what I will call some of the indirect effects of physical climate risk. The direct effects being you may have a piece of infrastructure that's subject to flooding. Your supply chain may be vulnerable to extreme weather, okay? Those are direct impacts. What I mean by the indirect impacts is the impacts of physical climate risk on the broader societal context in which your business operates, okay? So if you're a regional bank in Houston, your business may be vulnerable to out-migration. People leaving Houston because they're tired of getting flooded. Climate change has potential to be, as Sherry has outlined, to be a multiplier of drivers of conflict, of migration. All of these things strain the social fabric. Your business may be fine, but you may not be able to get insurance, and that's an indirect risk. So it's been interesting to me to see how much the threat that climate change poses to the underlying social fabric has resonated with decision makers in the world of business and finance. So I'm particularly excited about this work because I do think that these folks have the potential to be a powerful force actually in terms of controlling climate change. And I also firmly believe that if we're going to do that successfully, the private sector will have to play an important role.
Great. Thank you, Phil. So John, we'll move on to you. So the joint program really has been a pioneer in looking at climate, economic risks, and training students who are moving out and really doing some of the things that Phil has talked about. So can you comment on how our current uncertainties in climate change projections really affect our estimate of future risks in terms of society and the economy?
Sure. So when we hear the word uncertainty, some people react that, oh, well, this is an uncertain problem. Maybe we shouldn't deal with it. We should wait until the science is more resolved. But actually, the existence of uncertainty in this problem, and really deep uncertainty, really probably has the exact opposite effect. And so I want to lead you through a little debate in the economics literature that was started. Marty Weitzman up at Harvard kind of first described this, which has come to know the Dismal theorem. And the basic story is, if you have the distribution of true outcomes of climate, and they have a really fat tail, and we're not going to learn about them, we can't resolve that, and that fat tail extends into really, really extreme and catastrophic effects. We heard earlier from the earlier panel that temperatures of 8 to 10 degrees C warming could make huge chunks of the planet uninhabitable for mammals. We're mammals. That's catastrophic, right? And so even if the probability of that is fairly small, if you multiply a small probability that's not approaching zero rapidly times a catastrophic event, you get still an incredibly damaging event. And that can dominate the entire cost-benefit calculation. So that is Marty's Dismal theorem, and it's dismal because it kind of says that because some of these problems we aren't going to resolve it in the science until it's too late, we have to really speculate about these extreme risks and say, is there really damaging events out there? Now, Bill Nordhaus, on the other side, he won a Nobel Prize in economics on his work on climate change last year. He's somewhat dismissed this, saying, well, the conditions under which Marty's theorem holds up are kind of special. But more to the point, I think his argument is, what is catastrophic and how fat are those tails? So he kind of recalculated Marty's estimates, saying, well, and Marty focused on this climate sensitivity number that you heard people talk about earlier, because there are estimates in the literature describing what the probability density function of that looks like, and it includes some fat tails. Bill argued that Marty didn't calculate that quite correctly and got much lower numbers. But I think in my mind, one of the challenges in focusing on just the simple climate sensitivity metric and global temperature, I think we've heard of quite a lot of this already, that the global mean temperature is not a sufficient statistic to describe these risks. So we're already seeing that even with relatively small warming, this big change in tropical storms, we have the possibility of runaway climate change. We talked a little bit about that last time, unlocking methane hydrates that are in the permafrost and then causing a lot more warming, much more than we would expect, or even in paleo records, abrupt climate change as a possibility. You add in Sherry's threat multiplier insecurity, and you can see, in economics, we sometimes imagine that people are going to react rationally, but we come to solving this problem as a society. It's not clear that we're going to take a fully rational response when we start seeing these things unravel. Will we provide aid to countries that are suffering from serious climate consequences, or will we try to shut the door and tell them it's their problem? Will that devolve into a military issue and a problem? So I can see, far short of even the 7 to 10 degrees of warming, leading to some probability of these really high consequence events, and probably not as distant in the future as you might see 7 or 10 degrees. So these could start unraveling, over the course of the next century. So the bottom line is, if we do the simple cost-benefit analysis, say we have time to wait, how to take those catastrophic events that are low probability, that we even have difficulty speculating about, is the big challenge. But I think Marty's argument is we should do everything we possibly can as fast as we can. That still doesn't get to the answer of how do we stack it up about other problems we have. So getting at these, a big challenge for science is to help us understand how real these catastrophes are and how they might be. In the meantime, I'm not particularly worried that the world is going to act too fast. So I think the recommendation to do everything we can as fast as we can probably still holds.
Great. Okay, thank you, John. So we'll start taking some questions from the audience here, and this one could go to any one of you. So as the climate changes, some regions' climates may improve, and so at least in the shorter term. And so if that's the case, won't it make it more difficult for countries to agree on responses to climate change? And what do we do about that if that's the case?
I think, if you, so there's been a lot of discussion of that in the literature, and there's the idea that Canada might warm and that could make the climate better. Russia might warm and that could make the climate better. But there are also big risks in those regions from permafrost melting and other destructions. So it's hard to make the case. I mean, there is this sort of, some areas could benefit from some things, but there's a lot of risk to everyone. So I don't think it boils down to a simple story of there's going to be a bunch of regions that benefit and a bunch that fail. I think the risks are spread pretty evenly across different regions. And since we can't predict them very well, everyone has to worry about this. We don't really know what's coming, but it's probably going to surprise us, and it's probably not going to be good. So I don't see that as a big limit to reaching agreement. There's many other problems that are a problem to that, but that's not the biggest one.
Well, and of course, however we change, even if it seems like a change to the better, it's not something that people who are living in a particular region are adapted to.
Right.
So, which introduces uncertainty,
a very
just
important
as you
point.
said. So,
But I also
Carrie.
think it just denies the global implications of climate change. I mean, so my research would tell you that the Antarctic melts away, you're going to feel it in the Northern Hemisphere, as far away as that. So this local sort of idea, it just denies the essential truth about climate, that it's a global problem.
I guess I'd add to that. I mean, the thing that worries me the most is that to solve climate change really does require societal cooperation on all levels, international cooperation, cooperation among different sectors, and yet at the same time, the effects of climate change, I think, push in exactly the opposite direction. They push towards an every man for himself attitude, and in particular, the potential for massive international migration is a really, really worrisome trend. And I mentioned that, the Mediterranean region, North Africa, are going to see a lot more drought very, very quickly, and the Middle East, and there's enormous migration potential there. Central America, same story. Increases in drought in Central America are coming, okay? And if you think there's a problem at the southern border now, it's going to get a lot worse. And this kind of thing tends to produce international conflict at exactly the time when we need increased international cooperation.
Okay. There are a number of questions that we've gotten here that are along the lines of what I'll call climate justice and really build on a couple of things that have been said here already. So here's one that I think is indicative of a number that we've received. So given that the risks of climate change are disproportionately borne by indigenous and people of color, what should us in wealthy countries and wealthy institutions do to mitigate risks? And what's the role of the financial system, and how do we mobilize to make sacrifices in a way that doesn't exacerbate these inequalities? So.
I'll make one observation on that. Particularly with the very rapid climate change occurring across the Arctic region now, and indigenous communities, they're very directly affected. They're also much more engaged today in co-producing either the scientific or other knowledge that's needed to address it, or in looking forward towards the solutions. If you take the Arctic Council, for example, which is the governance mechanism for the Arctic, although it doesn't include security, but includes environment, commerce, data, science, search and rescue, and the like, and indigenous communities are represented heavily in that. And I think there's a growing recognition of the disproportionate impact of climate change on different communities, and at the same time an increasing recognition that indigenous communities and the learning, which can be different than in our in institutions like this and others, that the learning that comes from those indigenous communities is equally valuable in providing the local solutions that will be needed to address the challenges where people live.
So,
Phil?
if I can add to that.
That was kind of tepid, actually.
So a lot of the work that we do at Woods Hole Research Center is in the developing world. And the reason for that was mentioned actually in the previous panel, which is, this is where populations are growing rapidly. This is where economies are growing rapidly. This is where greenhouse gas emissions have the potential to grow very rapidly. And so I often say that the battle to control climate change will be won or lost in the developing world, and I believe that that's true. And so part of our work, well, one area we work on in particular is the Amazon, which has been in the news a lot. But the Amazon forest is an enormous reservoir of carbon. It also plays a critical role in regulating global and regional climate. So it's very, very important to help preserve, do everything possible to preserve the Amazon forest. And we actually work with indigenous groups for that purpose. And it's interesting how this collaboration has played out. And essentially what it comes down to is that the indigenous groups are in a battle for land title. They've occupied these lands forever, but they don't have the piece of paper, in the official legal system that entitles them to ownership of the land. And so that they're engaged in that fight, and we actually help them, and the way that we help them is by documenting that the indigenously controlled areas do a much, much better job at preserving the forest than the areas that are not controlled by the indigenous folks. And so we've documented that scientifically with measurements over time of standing forest carbon stock and so forth. And that gives them an important tool and an important piece of ammunition that they can use in their fight to get tenure over the land that they've always occupied.
Yeah, I have a couple of points maybe. One is, I think if we take poor, disconnected people without without health care and adequate food, and we start giving them health care and adequate food, they'll be much more resilient to climate change. So one is to just, we need to work to improve and help people get ahead, and those things will make people less vulnerable. So we need a fairer society overall to help. We can have targeted things around climate change, but a lot of it is education, preparation, and knowledge. The other aspect of it is, these things are wonderful, but you need money. And so a good reason to have a big carbon tax is it raises a big source of revenue, and with a new source of revenue, possibly that's the funding we could use in part for working on adaptation, on helping people adapt.
Great. Jerry, do you want to add?
So in Canada, land claim treaties are signed for 999 years. And we've worked with Indigenous Inuit and Cree on two projects that help them. One is to project forward in time what land will look like in 100 years and in 1,000 years. And this has incredible implications for resource management and resource ownership. But the other thing that we've done with them is that because sea ice is changing every year now in the Arctic, some of the elders in those communities lived through times where sea ice was always the same every year, year in and year out. And so what we've done is provided them with a tool. It's a portable tool that allows Inuit hunters, for example, to show a path that was safe for them so that other hunters can come behind them and not face the sort of problems that have happened in the last 10 years or so. But I really like Sherry's point, because what I learned in that project was that education, a lot of the learning in those communities are based on traditional methods, elders, and in the first year or two we weren't very effective until we realized that the best way to deal with these communities is to provide them with the tools, train them to use them, and get the hell out of there. Because they want to be independent, right? And I think that it's an important lesson we've learned just by trial and error, if you will.
Well, I'd say, MIT have put together a bold proposal called CruiseNet to actually develop projection capability for resilience in working. The first proposal is to try to work in Bangladesh, but we think this could eventually go global, working with the Lincoln Lab as well as groups in the country, NGOs with links to the people. So if we can get that moving, I think that would do a lot to kind of help poor populations around the world.
Great. So Sherry, here's one that's directly in your wheelhouse. Can we maintain military readiness without using massive amounts of fossil fuels?
That's a bit like asking, can we maintain our current lifestyle as Americans without using massive amounts of, fossil fuels? And I think the answer to that is look at California. California is twice as energy efficient, if not more so than the rest of the country, and the economy is still growing and is strong. So can we reduce the carbon boot print, if you will, of the military, which is the nation's probably single largest individual energy user, but still a very small part of overall energy? So it can't necessarily change oil and gas markets, but it is a technology engine. And if you look historically, a lot of the ingenuity, technology ideas coming out of MIT, Harvard, and other places have been taken through Lincoln Labs and other defense research centers, go right in to feed sort of the next generation of technology that has made our military the most powerful in the world. So can we do it in a more fuel-efficient way? Absolutely. Are we moving in that direction? Yes, we are looking at, the military is looking at, blended biofuels to power airplanes and how to reduce supply chain risk in powering our troops at the front. We lost a lot of soldiers and Marines convoying fuel to the front in Afghanistan and Iraq because we were trucking fuel to the front, and over the course of that decades-long war, we learned better ways to power our forces in remote bases using renewables, microgrids, and other energy-saving techniques. Are we doing this fast enough? No. Is it a high enough priority yet? No. But do we have the capability of making it such? Yes.
Okay, great. So for any of you, what are the main climate change risks for the greater Boston area beyond increased flooding?
Beyond what?
Beyond increased flooding.
Well, I think, we will expect to see a lot more extreme hot days. And so Boston is not the warmest climate, but a lot of homes are not air conditioned, particularly, again, speaking to the earlier thing,
That's great.
the homes of poorer people, and so they could suffer from extreme heat if we have those extreme heat waves. So that's certainly a big issue. We think of coastal flooding, but we're also concerned about rainfall creating flooding events, upriver, beyond just along the coast. So just because you don't live on the coast doesn't mean you don't have to worry about flooding. Those are a couple of the thoughts I have. Others may.
Disease.
Yeah.
I mean, disease vectors are changing and spreading. Here in Massachusetts and in Connecticut now, there's the threat of the triple E mosquito. I was at a wedding in Western Massachusetts this weekend. We were all given bug spray so that we could protect ourselves from that. So you find disease vectors spreading in new and different ways, and that's one of the understudied areas, I think, of climate risk overall is the risk to human health.
Okay, so we're actually winding down in our time, and I actually want to maybe ask the last question in an optimistic light. So the world's just seen one of the largest popular mobilizations in human history, the climate strike. Does this make you more optimistic that young people everywhere are ready to take direct action to force governments to take bold steps? And what would you recommend to the young people out there who want to put their energies into solving this global problem?
They vote. That's the most important thing.
It makes me more optimistic that people have picked it up. So yes, I think this popular opinion coming along, I think we are now seeing most industry accepting it, this young people and more of the public accepting it. It's only some of our political leaders that are lagging behind. But if we get people out and people vote and we put enough pressure, then maybe we can even change either their minds or the leaders.
Well, I agree with that. I think I'm actually, on the whole, not feeling super optimistic about about the future these days, but one of the things that does give me hope is seeing, it's just seeing the increased activism, and particularly the increased activism on the part of young folks who, and they're the biggest stakeholders, they and their descendants are the biggest stakeholders of all in this, so they should be, they should be jumping up and down. They should be voting. They should be otherwise engaging politically. And for you folks at MIT, I think it's a great thing to do with your life. If you have technical skills, to put those technical skills in service of addressing this problem. And I feel very fortunate that I have the opportunity to do that. I can just by going to work every day and doing my job, I can feel like I'm contributing. And I encourage you to think about careers that do that. And I'll say, one of the things that's, it's an opportunity. It's also a worry for me as a head of a nonprofit institution that's competing in the marketplace for scientific talent. I do think that as the world wakes up to the risks of climate change, and for example, the financial world, as I discussed, is certainly waking up to that risk, there's going to be a lot more employment opportunities for folks with climate science skills. So think about that when you consider career options. I mean, there's a lot more you can do than the traditional academic career options.
Youth movements, if you look throughout history, youth movements have been a force for social change. So there's no reason to think this one will be any different. It's just a sense of the magnitude. And, you know, when I was a graduate student at Harvard, I wanted to work on the greatest global challenges of that era in the Cold War. So I started out my career in nuclear weapons and arms control and national security. But I say my career went from weapons to waste and then into environment. But now I see my kids, my 2 college-age sons, they want to work in either clean energy, clean tech investing. They worked for climate investment portfolio companies this last summer. So, I mean, and that's their generation. And that's your generation out here. You all will be changing the world because climate change is the biggest global challenge of this generation and of our time. And so it's fitting that we should all be dedicating our time and energy to addressing it.
Okay, Jerry, you get the last word.
So one of the things that makes me very optimistic was going to some of the marches, realizing that young activists are very well informed. And there was a comparison that I thought was interesting. Somebody got up in one of the protests that I was at, and he was an academic, he's a scientist, he's saying we're extremely likely to face, and that's a very important term in IPCC language, and because we're always hedging a little bit, we're saying extremely likely, very unlikely, etc. And then one of the young organizers got up and stated a fact, because we've talked about uncertainty here, but there are climate facts. And she pointed out that in the 20th century, global sea level rise rose on average 1 millimeter per year. It is now rising between 3 and 4 millimeters per year. That's a fact. There's no extremely likely necessary. And what was really interesting about it was just how well informed those young people were and how willing they were to sometimes break through the academic resistance we have to say things with certainty. Because that sometimes gives people the idea that there is no certainty. But of course, there's a lot of certainty. Sea level rise has increased by a factor of 3 in the last 40 years, and there's no way around that. And they know that, and I think that's what makes me optimistic, that they know those things.
Great. Well, that's a great way to end our panel on risk, and let's thank the panel. Okay.
Well, this afternoon, you've heard and been able to ask questions from some of the very top climate scientists in the world today. I hope you come away from this event with a better appreciation of both the exciting intellectual challenges in climate science and the kinds of risks posed to humanity from anthropogenic climate change. These risks are real and very serious. As my field continues to tackle the scientific challenges of climate, and with any luck better delineate and quantify the risks associated with climate change, we must, in parallel, work hard to deal with those risks. We can't afford to wait. The next 5 symposia deal with climate risks and solutions. The next one, Challenges of Climate Policies, on Tuesday, October 29th at 4 p.m. in the Wong Auditorium. Subsequent symposia explore decarbonizing the electricity sector, economy-wide decarbonization, MIT climate initiatives, and the role of research universities. And a final symposium addresses the important question of why the world is waiting. We hope you will join us for this exciting sequence on climate. And now, please join me together with the other organizers, speakers, and panelists for a reception and student poster exhibition in the lobby. Thank you.